Welcome to a video on graphing a function using transformations. For this problem, graph the function p of x, which is defined as -2 times the absolute value of x minus 1. To graph this function, we need to start with the graph of the parent function. Let's define that as f of x, which is the absolute value of x. Note that the graph of the absolute value of x is a V-shaped graph with a vertex point at the origin, and for every integer value, the output is the absolute value of that integer. So we'll use 1, 1, 2, 2, 3, 3, and so on. To graph the function p of x, again, note that the -1 inside the absolute value function is a shift of 1 unit to the right. And now the -2 in front indicates that it's a stretch of 2 units vertically. And because it's negative, we're also going to reflect that along the x-axis. So let's combine those two transformations at the same time. So basically take all the y values and multiply them by -2. That will stretch vertically and reflect along the x-axis. Using a few points on the graph of the parent function, I'll go ahead and use points -2, 2, 0, 0, and +2, 2, and transform them. So first, 1 unit to the right, and let's indicate this new graph in a green color. 1 unit to the right, and now take the y value there, times it by -2. The y value is a +2, times it by -2 is going to give us a -4. So x stays at -1, but y is now at -4. So that red dot there is transformed to the new location of -1 followed by -4. We're going to do the same now with our next point. So shift 1 unit to the right. It's now at 1, 0. And now take the y value there is 0, times it by -2, which remains at 1, 0. And now our third point, shift 1 unit to the right, take the y value there, which is a 2, times it by -2. So that becomes -4, which means the third point is now located at 3, -4. And remember, this was the vertex point that was transformed. And now we're going to connect those 3 dots using the shape of the absolute value graph. So instead of having a regular V, it's an upside down V due to the reflection along the x-axis. And if we compare the general shape to the absolute value graph of P of x is more narrow.